Hi everyone, this is Ginny, Assistant Professor from Information Technology. Today lecture is Operating System. Course outcomes, understand the various schedule algorithm, context deadlock prevention, various memory management schemes, functionality of file system, IO system, compare iOS Android operating system. Syllabus covered introduction, process management, memory management, storage management, virtual memory machines, and mobile operating system. Today topic is process synchronization. So in the process synchronization, there is a critical section problem, synchronization hardware, semaphores, a classical problem of synchronization, critical regions, monitors. First one is race condition. Race condition. What is race condition? Race condition occurs when two or more processes or threads access and modify shared data at the same time. And the final result depends on the order of execution. In simple words, the system results depend on who runs first. The situation where several processes access and manipulate shared data concurrently. For a simple example, suppose we have a shared variable, two processes execute. Process 1, process 1 equal to x plus 1, process 2 equal to same x plus 1. Expected result is x equal to 7. But what may happen without synchronization? P1 reads x equal to 5, process 1 reads x equal to 5, process 2 reads x equal to 5, then process 1 updates x equal to 6, then process 2 updates x equal to 6. The final result is incorrect. This problem is called final result equal to 6. So this is incorrect. This problem is called a race condition. Then why race condition is necessary? Shared memory access, no synchronization, concurrent execution, critical section problem. Then next one is critical section problem. The part of code where shared variables are accessed is called the critical section. To avoid race condition, only one process should enter the critical section at a time. Solution to race condition: mutex, semaphore, monitor, like this. Then critical section problem. What is first of all critical section problem? A critical section is the part of a program where shared data, that is data means maybe variables, files, memory, is accessed or modified. If multiple processes enter this section at the same time, it may make a race condition. What's the critical section problem? The critical section problem is the problem of designing a protocol so that only one process executes in the critical section at a time. In the structure of process may be entry section, critical section, exit section, remainder section. So the solution, next is solution to critical section. Solution to critical section problem is mutual exclusion, progress, sum of monitors, semaphores. Mutual exclusion. Mutual exclusion means if a process P1 is executed in a critical section, then no other process can be executed in the critical section. Progress, if no process is execution in the critical section, there is exit some process. Next one, bounded waiting. Then synchronization hardware. What is synchronization hardware? Uh, Here is test and modify the content of the word automatically. Here is some codes. Boolean test and set of boolean of target. Boolean RV equal to target. Target. Some code is here. Boolean test and set. That is boolean target. That is function name is test and set. Target passed by reference. It modifies the original variable. Boolean RV equal to target. Store the current value of a target in variable RV. Target equal to true. Set the target variable to true. That this means lock is now occurred. Return RV, that is return the old value of a target. All these are how it works in critical section. We you use a shared variable C. Boolean lock equal to false. While test and test lock, wait busy waiting, critical section, lock equal to false. If lock equal to false, test and set returns false. Lock becomes true, process enters critical section. If lock equal to true, test and set returns true. Process keep waiting. Then next one, mutual exclusion, test and set shared data process PA. That is shared data is a boolean lock equal to false. Lock is shared a variable. False critical section is free. True means the critical section is busy. Then process PD this coding do while loop critical section. So that is while loop is the test and set lock. There is the entry section. If lock is false means the test and set returns false. Lock becomes true means process enters critical section. If lock is true, test and set returns true. Process keeps waiting. So only one process can set lock equal to true first. Then only one process enters here at a time, which will exclude is guaranteed. So lock equal to false. This is the exit section. After finishing the critical section, process releases the lock. Now another process can enter. Now normal execution outside the critical section. How it ensures mutual exclusion? Because test and set is atomic. Only one process can change the lock from false to true. Others must to be wait. So two processes cannot enter critical section at one time. Then another example, automatically swap two variables. That is a word swap of boolean lock equal to false, then boolean waiting of n. Lock equal to false, critical section is free. Lock equal to true, critical section is busy. While key equal to true, key equal to true, there is an automatic instruction. Then mutual exclusion with swapping, that is shared data initialized to false, then boolean lock, boolean waiting of n, then process I do key equal to true while key equal to true. So, already I said the critical section lock equal to false. Then semaphore. What is semaphore? Synchronization tool that does not require busy waiting. Semaphore is the integer variable, so can only accessed in two indivisible operations. Semaphore is a synchronization tool used to control access to shared resources and to solve the critical section problem. It is an integer variable accessed only through two atomic operations. Wait off, signal off. Wait off means also called P operation. Signal off also called V operation. The types of semaphore. What are the types of semaphore? One is binary semaphore, counting semaphore. Binary semaphore means values. Binary means 0 or 1. Used for mutual exclusion, similar to log. Counting semaphore. Value can be 0, 1, 2 up to n. Used when multiple instances of a resource exit. Then operations on semaphore. Assume CFID equal to semaphore 1. Semaphore yes. Wait, its degrees value. Then weight of yes. In while of yes less than or equal to 0. No, so yes decrement. Then s greater than 0 means enter. S equal to 0 means wait. Then it for least resources allow another process to enter. Both operations are automatic. Then how to working? If mutex equal to 1, process enters. Mutex becomes 0 means other process must wait. After finishing, it's make it again. What are the advantages of semaphore? Avoids race. Main advantages is it avoids race condition. Can handle multiple processes. Then better than busy waiting. And also disadvantages. Programming errors may be case deadlock. Incorrect Ordering make a starvation. Th- Thank you.